Algebra 2, Worksheet 21.2, this is number 6. We're asked to solve this equation and determine whether it has real or complex roots. I've written it here on the line paper, so I'm marking. What I'm going to do is I'm going to start by moving the 5x over. Normally we would move everything over, put equal to 0, and try to solve that way. We would factor or maybe do quadratic formula. But I'm going to just move the 5x over, and you'll see why in a second. So this positive 5x is going to subtract from both sides. It leaves me with x squared minus 6x, negative 1 minus 5, equals, the 5x's cancel, negative 25 stays there. Now the reason I only moved the 5x is because now what I can do is complete the square. I can take this b value, negative 6, divide that by 2, and square it, and then add that to both sides. When I do that, that becomes 9 and 9. Now you could still move everything over and try to factor or do quadratic formula, but this usually seems to be the easier version of it. Now when I complete the square, I'm able to factor it so that it is one quantity squared. Square root of x squared is x, square root of 9 is 3. This sign in front of the 6 comes down, which gives me x minus 3 squared. I add these together, I get negative 16. And now to get rid of this square, I'm going to take the square root of both sides. This side leaves me with x minus 3. And now I've got this square root of negative 16. This is what makes our answer complex, because now I can't take the square root of a negative, but I have that fancy imaginary number. So when I take the square root of 16, I get 4. The negative becomes I when that comes out. Remember, anytime you take the square root, it's either plus or minus. The last thing I need to do is move that negative 3 over, so I'm going to add 3 to both sides. That positive 3 goes in front, plus or minus 4i. There is my answer. So now when I'm writing my answer here, this is a complex answer because I've got the imaginary number in there. And that complex answer is 3 plus or minus 4i.